Can you guys see my beautiful blue screen?
Yes.
Yeah, I can see it.
Good. Okay, so this is what we're gonna do. How many of you guys have, what is it called? Chromebooks? Nobody? Excellent, that makes it easy.
I do.
Okay,
I just have HP, whatever that is.
you have an HP? That's perfect, as long as it's not a Chromebook.
Okay.
Okay, so what I'm gonna have you guys do is, I'm gonna have you guys go to the very top where it says you're viewing Dr. Henry's screen or Kenneth Henry's screen or whatever. Do you guys see that at the top?
Yes.
Yeah, next to view options.
Yes, next of it, it says options.
Mhm.
Okay, now when you hit those options, one of them should say annotate, A-N-N-O-T-A-T.
Mhm.
If you select that, you have, it says select text, draw. Hit the draw and hit the squiggly line, and then sign your name on my screen.
Oh, oops.
Mhm.
I don't like this.
Is there any way you could re-explain that? I literally just joined right now, please.
Sure, I can. So if you go to where it says you're viewing Dr. Henry's screen or you're viewing Kenneth Henry's
Mhm.
screen, okay? Next to that, it'll say options. If you select those options,
Uh-huh.
on the options menu, you want to select annotate, A-N-N-O-T-A-T-E. And
Mine only says fit to window, original size, and request remote control.
okay, so that means that you have a Chromebook. Do you have a Chromebook?
So I'm poor. No, yeah, I do.
Yeah. So then that means that you won't be able to do it. Although
Oh,
you're
okay.
able to share your screen though, which will be just as good. And
Alright.
then you should be able to write on your screen.
Okay. All right.
Okay, now who was that said that they had a Chromebook though?
Jacob?
Jacob? Okay,
Yeah.
Jacob.
And I have one too.
Okay. So, and who was that says I have one too?
Sarah Gonzalez.
Okay, Sarah. Okay, good. So I know who has Chromebooks. That'll make it easy, right? So then I'll make you guys share your screen when I ask you questions. Okay?
That's messed up, man.
That's just how it works, you know? It's love. It's just love in a different way. That's all.
Mhm.
We've got to make it work. Okay, did everybody sign the screen?
Yes.
Anybody not sign the screen except for Jacob and Sarah?
I haven't signed it yet. I'm trying to sign it, but a whole bunch of squigglies.
Okay. That's usually how it works when you're using your mouse key, you know. I want to make sure everybody signs it. Because I could have sworn I had more people than this.
Maybe they got COVID.
Well, they still should be here. They can be in bed. It's a nice way of learning chemistry, right? If you can learn chemistry through COVID, you can learn chemistry through anything.
2 of them are logging in right now.
Okay. Good. So nobody decided to go to campus? Everybody got my message?
Not everyone checks their Canvas messages, so I sent the message to them.
Okay, thank you.
I didn't want no one driving over there if they didn't have to.
Yeah. I'll go run and check the door here in a minute, but. So for the next 3 lectures, we're gonna have to do it, or the next 3 meetings, we're gonna have to do it this way. Apparently, a couple of you guys went out, partied a little too hard, right? And that brought a little COVID home. So as a result of that, we have to kind of stay away from each other for a little bit. So on Thursday, we will have the official day that you guys can coming back to campus, as far as I know. And so that kind of pushes a damper on a couple of things. You won't have your labs to get done. That also is going to push back your exam a little bit too, okay? Even though your exam is done online, there are a couple of things that I wanted you guys to do face-to-face because it kind of helps understand the material, okay? So are you guys crying over that? If so, we can make things work. I give you your exam right now, you know.
Wait, what's the question?
I said, are you guys crying over the fact that I'm going to be pushing back your exam by a little bit?
Oh, that'll be helpful.
Mhm.
Okay, so let's go ahead and get started. Everybody signed it. So the next thing I want you guys to do is, if you go in the corner of your annotate and you hit save. You guys see that save button? And then it says show in folder. After you clicked it, it'll pop up the images that you saved. So if you've done all of this work and you wanted to keep an image of it, you guys can actually save the screen that we just did. Right?
Oh, cool. The screenshot.
Okay. So you guys all see that?
Yep.
Yes.
Okay, so I'll be honest, I'm horrible at checking my chats, although they do show up on my screen. I will try to keep an eye on them. And the other thing is that you guys also have certain controls, like you can give me reactions. Like if you understand things, there's a thumbs up. Do you guys see my thumbs up on my image?
Yes.
Okay. If you don't understand things, there's the tears, I guess that tears of joy, but we'll use the big open mouth, like, oh, what the hell, okay? So if you don't understand it, let me know that, like, oh, you know, okay? So just in case you don't wanna comment or something like that, just give me that image, it'll help me know what's going on and what you guys are thinking. You guys are with me so far? You see all of the different reactions that you have?
Yeah.
Okay, good. Okay. So what else should I tell you before we get started? So like I said, normally we would have a lab today, but that's been changed because of the class. So I'm also going to take 5 minutes so you guys can chit chat. I'm going to run over to see if anybody made it to the classroom because there are a couple of you guys that aren't logged in. So I will be right back. You guys can handle it without me?
Yeah, I got this.
Okay, good. Let me not lock myself out.
Well, don't do that. Has everyone had dinner?
Nope,
No.
not me at least. Did you?
Oh, let me guess. That was Gabriel. Where is he?
No, it's Edwin.
Edwin?
I'm not Gabriel. No.
I don't know all your guys' voices yet, Teddy.
That's actually that's my middle name though.
Gabriel? Edwin Gabriel? Oh. Very proper.
Yo, I was in my living room. It's way too loud in there. I had to come to my room. Let's go. What about you? Did you have dinner?
I'm eating right now.
What are you grubbing?
Cocktail camarones.
Oh, wow. Well, that's a little fancy for the night.
It's
That's
hot
a-
out. I didn't want to cook too much food. It's too hot to cook.
That sounds good though. That sounds really bomb. Give me a second.
My apartment's very quiet. My neighbors only party on the weekends. Hey, bro, I saw that.
Hello.
You look like a
look-
game, like a streamer person.
I look fat. Jesus Christ.
Look at me, I'm in my blanket hoodie.
Ah. So this is how everyone sees me. It's terrible. Edwin, we can't hear you.
Yeah, your mic's off.
He's laughing. All right. So what happened?
Did you write your name on the screen?
Oh, we have to do this?
He wanted to, I don't know if we're supposed to, but he was just showing us how to do it and then save it, so that way we can save it to our notes, I guess.
Oh, do we do this?
He said to go to view options and then click annotate and then do the little pencil and write your name. And then something about on the right side, click save after and then show folder, and then it'll be like a screenshot in your folder.
All right, I'm back. What happened? How do I do this?
Oh, Jesus Christ, I'm gonna kill you. This is being recorded, so are
I
you
know
listening?
that. Yes.
Are you listening? Okay.
Yes.
On the
I
top
look-
of the screen where it says Mr. Henry's screen and then it says view options. Okay, click annotate.
All right.
All right, now do the pencil.
The pencil?
Yeah, there's like a skinny little pencil. It's tilted.
I see draw.
Let me see.
I mean, it should work. Oh, there it is.
And then just write your name on the screen.
Oh, let me change colors. All right.
Okay, now.
Now let me fix this. Let me change it.
Jesus Christ. Edwin, your mic's not on.
Oh, that's
There it
all
is.
right. I was
No. I'm gonna do that again.
Go ahead, Gabriel. Gabriel, are you all caught up? Good job, Brooke.
That's
Doing a-
right.
doing a
What did
good
I
job.
what did I
Okay.
miss?
After you write your name, he wants you to click save and then click show in folder. And he just wanted to show us how to like do a screenshot of this so that way we can save it for our notes or whatever.
All right, so I save it as PNG.
Sure.
All right.
That's all he said to do. He went to go make sure no one showed up to class.
All right. I
How much
did
you want
it.
to bet people would like show up and then just like leave, like right off the bat? Like I'm not gonna stick around if nobody's in the classroom. I would dip. There he is.
I feel like if I was the only one in the classroom, I would open my computer and check to see if Zoom was on and then just stay there
Right.
since I'm already there.
Okay, what a goat.
Hey, everybody here?
Yes.
Somewhat,
I
Somewhere.
think so.
maybe.
Sonia, are you here?
I have 25 people.
That's not bad. That's not bad. Let's see.
She said yes.
Is this what I look like?
Don't worry about what you look like, brother. Hey, did you play the PS5 today?
Well, yes.
What did I tell you?
Yeah,
I mean,
what did he tell you? Or what do you want me to tell you?
be successful,
Priorities.
remove distractions, create
Yes.
routines.
Yes. Remember, you have to build that habit. To
Yeah.
be successful, you have to build healthy habits.
How do I
Edwin,
get rid of all this writing? Because we can see
Wait,
your
wait,
presentation.
who is
but
who
no
is this
writing.
talking about building healthy habits? I want to know this person.
It's Edwin
Yeah.
Edwin.
Aguilar.
Okay. Good job.
Yeah, but I'm obese, so like healthy habits doesn't really like
I mean, me
go with
too.
that. You know, I do have bad eating habits. Don't get me wrong, but
I mean, I need to fix that as well. Like,
being successful is
I wish
different
you
than being
luck.
healthy.
I consider both pretty similar.
But that's good. That's good, Gabriel.
But
No
you
more-
know, it's like,
No more PS5 then. No more.
You got a
It's
PS5?
not that- no,
I'm
no,
gonna find
no.
your door.
No, the thing is, you can do it, but you need to moderate.
yeah.
Moderation is the best thing. You shouldn't,
Which
it's all about
reminds me,
moderation.
A balance. Okay.
since
Balance.
now is the
exactly.
time.
Yep.
What did I miss on Wednesday? So Wednesday
Oh, you
was a
missed a
lab.
lot. You missed a lot. You'll
And
have
the
to watch the
quiz.
video. You have to watch the video to see it. So,
You missed
Right.
a shit ton, bro.
okay, so now you're gonna miss some more if you guys don't get started. Okay, so last we left off, I believe we talked about the metric system. Did we not?
Yes.
Yes. Okay, good. And we know that the metric system is based on tens, multiples of tens, right?
Yeah.
Yeah.
Okay,
I
good.
guess.
Okay. Did I talk to you guys about SI units?
SI what?
SI units. International. Well, so it's
I don't
called
remember that.
System International, right? So those are the units that, because we're scientists, right? It's all about communication. We got to be able to communicate. Remember, I talked to you guys about this communication,
Yes.
Sure.
right? So for us to communicate, we need to be on the same page, right? So we need to be able to kind of speak the same language. So the SI units are kind of like learning the same language. So we use the metric system because most scientists in the world are going to be using the metric system. So as scientists, we want to do the same thing that they're doing so that everybody's able to communicate, right?
Yeah.
Because not everybody understands what a pound is or what a foot is. And so
We're like the only ones that use that.
yes, exactly. Everybody else uses the metric system. And so we have a standard system that everybody basically uses. And within that metric system, there are certain ones that we most of the time will use. And I'll talk to you about that as we go through. Okay, so the base unit. The base unit is the unit that we're going to be using for that particular measurement. Like for instance, if we're talking about mass, what units do you use for mass?
Volume?
No, that would be another base unit. Volume would be another base unit.
You mean like
What would we
grams?
use for mass? Somebody said grams. That is
Grams?
correct.
Oh,
yeah, that was
dubs.
me.
Oh,
What
yeah.
was
That
that?
was me.
Oh,
Whatever. It's okay. Don't matter. It
it's
doesn't
all
matter.
good, bro. Hey,
Mass.
if we're both good, we're both right, then it's all good.
It
Yeah.
is. Yeah.
Okay, so we have grams. What else?
Ounces.
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 All right.
Liters? Milliliters?
Nope, those are all
Liters and
volume.
Pint.
Right.
Oh,
Mass. Think about weight, right? Because we associate often
pounds.
use it. What was that?
Kilograms?
Kilograms. Yes, kilograms.
Would pounds be a part of this too?
That's right.
All right.
And this is all recorded, correct?
This is going to be recorded. Yes.
All right.
Okay. What else?
There's more for mass?
Yeah.
Inches?
No, inches would be distance.
What is LB?
Pounds.
All right. Pints. But no, that's
No.
volume.
That
That's
would be
volume.
volume.
Grams, ounces, pounds, kilograms. Is there one more?
There's quite a few more, but if we could get one more, that'll be great.
This is Joe's
Decagram?
mother.
We have hectogram, decagram.
Oh, we got
Tons.
hectogram, dectogram. Good
A
job.
milligram?
Tons.
Tons.
Show
There we
off.
go.
Okay, cool.
See, this is where Google comes in handy, my friends. This is not from my brain.
I heard milligrams.
Joe's mom. Never mind. Nobody gets that. Hey, someone got it. Are we including other nations' versions of, mass
Yeah.
measurement?
So what are
Okay.
other nations' versions of mass? Most of those should be in the metric system.
do you want decagrams?
We could have decagrams. Yes, that would work as
Okay.
well.
All right.
Okay, so now those are all mass units, right? So
Mhm.
for mass units, the SI unit is the kilogram. The kilogram is considered the units that we use most of the time, although it really depends on the quantity or how much we have. So if we have a small amount, right, and we know that it's going to weigh less than a gram, we're not going to use a kilogram to sit there and do the measurements, right? We're going to use a milligram or a microgram, okay? Now, that means that our base unit, which I boxed here, is grams. So that's going to be our base unit for mass. And again, we'll talk about this a little bit more, but I want you to understand that we use grams, right, as our base. Okay, so that means that we can use those prefixes. You guys notice you had mentioned a couple of them. You had kilograms. Kilogram, kilo is our prefix. We know that a kilo means that it's 1,000 times greater than the gram. The hectogram, hecto is 100 times greater than the gram. Milli is 1,000 times less than a gram. Decagram is 10 times greater than a gram. Okay, so we use prefixes to sit there and help us with that base unit, to let us know the scale that it's at. Does that make sense?
Yes.
At least a
You
little
said
bit right now.
hecto means 100?
Hecto means it's 100 times greater than a gram. Okay. So if we talk about volume, since you guys were really anxious to talk about volume, can you guys give me some units for volume? Can you see that on my screen? Volume?
To the right, yeah.
Or is it being blocked by images? I can put it all on the other side if you need
That's
that.
good. Move my people around.
Milligrams was how much less? 1,000 times less than a gram.
It is 1,000 times less than a gram.
A decagram is 10, right?
Decagram is 10 times greater
Yeah,
than
10 times
a
greater,
gram.
and then like hectogram.
A
is 100
decigram
more.
is 10 times less than a gram.
All right. Thank
Okay,
you.
so now we're talking about volume.
A decigram was 10 or 1? No, or
It's 10 times less than a
All right.
gram.
thank you.
Liter, milliliter.
We have liter. All right, milliliter. Anything
Pint.
else? Pints.
Liters. Oh, right.
A gallon?
A gallon.
A ton.
Fluid
No.
ounces?
Fluid ounces.
A ton doesn't count? What
No,
would
a
it be?
ton is mass.
Ah. Oh, yeah, I see now.
So is mass for solid things and volumes for liquid?
Yeah, volume is the space that's being occupied. Mass is, it's the measurement of weight.
Weight.
Or measurement, well, what we think of as weight. We kind of have to change our definition.
Okay.
Okay. Anything else? Anything that you guys use in the kitchen?
Like cups or no?
That's right. Who said that?
A cup?
Yeah, a cup.
Yeah, it's
measuring cup?
space.
A spoonful?
A
Oh, there's
spoonful.
tablespoons?
Oh, you guys are getting fancy now. We have a teaspoon, right? Wow, I'm impressed.
Yay.
This is dumb.
Tablespoons, teaspoons.
Tablespoons, teaspoons.
Is there more?
Yeah, there's more.
Shit.
What's that soup spoon?
It's a soup spoon,
Bro said
A
fun.
ramen spoon?
a ramen spoon.
Isn't there people from other countries here? Like, do they have answers?
I don't
Well, they
think so.
probably would use a pint.
Uh,
Because it's
They probably
described
just use a
beers.
regular ass spoon.
Yeah.
Bro's
What about a
referring
quart?
to-
quartz?
Oh, quartz. They have that on the Kool-Aid thing.
Thought that was a science term.
No,
Oh,
it's a
no.
measurement.
Like the star.
They're
no,
all science
the
terms,
atoms.
right?
So how much is
Well,
quartz
yes.
then? Is it like 25 or something?
So what is it?
Pints.
16.
The size of an atom, no
Yeah.
less.
So 4 quarts is a gallon.
Oh, okay.
Okay. So these are all examples of volume. So when we talk about volume, there's others. There's more. There's more. So if I'm looking at a cube, how would I measure that? The volume of a cube.
By its like area.
Base times width times height.
Base times width times height. So what would be the units that I would get at the end of the day?
Oh, what units is the thing?
It's
How big is the
Centimeters?
cube?
You
Say
go
that
with-
again?
Centimeters?
Centimeters. So cubic centimeters.
Ah,
Anything else? If I have cubic
Inches.
centimeters, I could have cubic feet, right? Come on, Americans.
a
I could have a cubic mile.
mile. Isn't this distance?
No, it's volume
Amazing.
because it's cubed, right? So I could also have a cubic meter. Okay, so a few years ago, the leader has taken over as being the SI units for volume.
What was it before?
It used to be cubic centimeters. I mean, cubic meters. How many of you guys watch the medicine shows like Grey's Anatomy, Chicago Hope? I can't think of any off the top of my
Watch
head.
Grey's Anatomy.
Okay, so
Wait.
how often do you hear them say, I need 5 cc stat?
Oh, CCs.
So what does cc stand for?
CC is ml. Oh,
Right,
cubic
cc
centimeter.
1 cc equals ml. What does it mean?
Cubic. I said it, but I forgot.
You said cubic centimeters. That's right. So it means cubic centimeters. It's the same thing as this right here. Right? And we know that 1 cubic centimeter, or in medical terms, we'll see it as 1 cc, equals 1 milliliter.
Yeah, they don't use CCs anymore because they get confused as zeros. But we still have to learn it. It's important to know our roots.
What is CC abbreviated? from?
Cubic centimeters.
No, CC.
Cubic centimeters.
All right.
CC, cubic centimeters.
Yeah, I know. I got it now. Sorry.
Okay. So other base units. So the base unit for the SI, this is also happens to be the base unit, the liter. As you guys know, milliliters, we talked about it earlier, milli, that's that prefix, and then liters is the base. Okay. So distance. Everybody got this down?
Yes.
If not, you can take a screenshot by hitting save.
Um,
Okay. Distance. Okay. So what are some
Inches.
inches?
centimeters, meters, kilometers, miles.
My boy's on a roll right now.
Centimeters. I heard
Light
millimeters.
years. No, wait, light. Yeah, light years.
Light years. That's an interesting one.
I mean, it's a they use it all the time.
Star Wars.
Meters?
Yeah. Buzz Lightyear, you know, the movie that's failing right now.
Hey,
Mhm.
it's a good movie. I like socks.
But it's like the ads are annoying. I mean, it was playing for like a solid month, you know?
Pay for no ads.
Okay, so
That's true.
back to units of distance.
Yards,
Yards.
feet.
What's a bigger measurement
feet
than
and
miles?
yards.
Light
Um,
years.
Um,
I heard feet.
Oh, yards.
mile.
That's a good
A
one.
kilometer is much longer than a mile. No, wait, no, it's
No, it's
shorter.
not.
It's
A
shorter. It's like,
kilometer.
Is it
Point-
shorter? Is
yeah,
it?
it's like 0.8 miles. Yeah, a kilometer is like 0.8 miles, right?
Okay. I forgot actually.
You have a conversion table, right?
Hmm.
Not on hand right now.
It's on our packet with the periodic table, right?
That's
Mhm.
right. What else? What else? What would be the base unit for kilometers?
Kilo. Oh,
Kilo
no,
would be the prefix.
my fault, my fault.
Prefix means before. So then the base
A
would be
meter.
what? Meter.
A meter.
That's right.
So we just go in meter. Okay.
Okay. So the meter is the SI unit, and it's also our base unit.
Now, what is the definition of SI?
SI means it's the units that we basically use in science. So it's the
Okay.
it means for it's System International. That's why you get SI. It's,
Okay.
we say it as the International System of Units.
We say
sure.
everything backwards in English.
System.
Okay.
Systemea.
I grew up in Mexico and these would be the ones that we used. It wasn't
That's
until I got here that I started to see gallons and like miles.
Jacks everybody up.
Yep.
I'm not from
All
Mexico.
Yeah,
the
and then like
YouTube
when you guys
videos
come
I
over, you're
watch-
like,
That's-
what the hell is that? You have no concept of it, right?
The Australians.
Yeah, that's
all
like
the YouTube
us.
videos I watch.
Us
Oh.
in the States, we don't have a concept of like what a liter really is, although we have 2 liters of bottles, right? 2-liter bottle of soda. We have an idea of what 2-liter bottle of soda is, but a liter, struggle.
Man.
Yeah, like gas would be per liter. We would buy gasoline like per liter, not per gallon.
Wow, that's actually pretty interesting. I had no idea.
I
This
don't.
is good to know. My fault.
So time. What are units of time?
Seconds, minutes, hours, days, night,
Slow it down to
Years.
milliseconds.
milliseconds.
Second.
That's true.
I heard millisecond.
Yeah, we can go in order if you guys want.
And I heard days,
Days, hours, minutes.
hours,
Century?
century.
Decade, year.
decades, millennium, eon. Wait, no, eon is,
Did you even say minutes yet? Yeah, minutes.
yes, I said minutes, days, no, minutes, hours, days, months, weeks,
Years.
And then
years.
infinite, and then infinite at the end.
No.
Yeah, do a little infinity sign.
Yeah, cause it's cute.
Decades. Okay, so the base unit here is going to be
Millennium.
seconds. Millennium, that's right.
Is eon a measurement of time?
It is a measurement of time.
Really?
Yes.
I thought it was a general term for a specific era.
Nope.
So that how long is an eon?
I have no idea, but it's a measurement of time.
All right, let me look it up.
You can look it up. That's what Google's for.
Hmm.
Okay, so we have time. So we've talked about time, volume, and mass. Anything else? Distance.
1,000 million years.
Okay,
Eon.
What about
so let's
speed?
get into that metric system. So we know that there's that base, right? So seconds, if we're using seconds as our base. So we could have a millisecond, right? We could have a kilosecond.
Is it millisecond like MILA or MILI?
MILLI, milli, mil,
Oh, like that old song, a milli?
yes.
A milli, back I'm going.
What?
Exactly.
A million here, a million there. Yeah, okay.
Okay, so if we take a look at it, so these are the prefixes that you're going to be using. Again, you're going to be using the base of either grams, meters, liters, seconds, right? So those are going to be your base units. And so these are the prefix that you'll be using for it. So if it's 10 times greater than a gram, then it's going to be a deca. If it's 100 times greater than a gram, it's going to be a hecto. If it's 1,000 times greater than a gram, it's going to be a kilo. If it's 1,000,000 times greater than a gram, it's going to be a mega. If it's 1,000,000,000,000 times greater than a gram, it's going to be a giga. There we go. Sorry, I got ahead of myself. So million, billion, then a trillion, it's a tera.
Is giga the same thing we use in gigabytes on our phone?
That is correct.
Cool.
Well, megabytes too, yeah.
That's right.
There's
Terabytes.
kilobytes and then just bytes.
Terabytes.
Then there's petabytes.
Okay. So if we go the other way, if it's 10 times less than a gram, it's going to be a decigram. If it's 100 times less than a gram, it's going to be a centigram. If it's 1,000 times less than a gram, it's going to be a milligram. If it's 1,000,000 times less than a gram, it's going to be a microgram. And the microgram here, if you notice the abbreviation that you're going to use or the symbol that you're going to use, this symbol is called mu. That's called mu. MU, mu. Okay.
Why is it called that?
Because we can't use M anymore because we're using M here for milli, and then we use capital M for mega. So you want to make sure that when you're using milligrams, you're using little m, not capital M.
But when you pronounce it, it's just mu?
Yep.
Mu.
It's mu. It's mu.
It's like M-U.
Like Mewtwo?
MU. Mu.
Oh, M-U.
MU. Mu.
Oh. Okay.
Okay.
Mu.
Okay. So Nano is 10 to the minus 9 smaller than a gram, right? So, and we use an N, nano 9, and here we have minus 9, right? Pico is 10 to the minus 12. Okay. Questions? No questions? Good.
For the quiz that I missed, I was supposed to do it with Miss Norma today at the SPS.
I
they were
forgot to give
gone?
her the quiz. I'll have to
That-
email
yeah.
it to her.
All right, thank you.
Okay. Thank you for reminding me.
Welcome. Also the lab, I missed that too.
Yeah, you're gonna have to try to find a time to make that up. So we'll talk about that.
I just asked the people I know for help.
No, you actually are gonna have to do the lab. So
Okay. Angie said, no, Angeli said there was it was about data because you guys didn't finish it yet.
we also did the last week we did the measurements lab.
All right. And we're supposed to continue it, right?
No, you guys finished the measurements lab.
What? All right.
Well, I thought you still had to go over the scientific notation part, like the first part.
Oh yeah. Sig figs. Significant figures. We will be talking about that today. So then after we talk about it, then you guys will be good. You're right, Angelia. My bad. See, that's what a 3-day weekend just throws me off.
Did you party hard though?
Oh, really hard. I was here in the office.
Oh my gosh.
What kind of partying is that?
Well, you know.
Dang, that's tough, dude.
Then I went to my dad's and had a couple of beers and had barbecue.
Oh, sweet. That
sounds
works.
Yeah, so I had to make up for the time that I spent in the office.
That's not enough time, but okay.
Yeah. Okay, so mass and weight. So even though we have a tendency of mistaking mass for weight, there is a distinction between them, right? Mass is going to be the measurement of quantity of matter. Okay. Weight is going to be measuring the force of gravitational attraction on a body. So when we talk about the pounds, so that is basically force. That's going to be associated with the body, right?
That's what's holding
how
us
much
down?
force is being put on the body. What was that?
So that's like what's holding us down on Earth?
Sort of, yes, exactly. So if I want to measure my weight, is my weight going to be different on the Earth compared to the moon?
Yes.
Yes.
Yeah.
And why is that?
We're light as a feather.
Because of gravity.
Because of gravity. The gravity is different, right? So the force of gravity is different on the Earth. It's 16 times greater than it is that on the moon.
I'm letting you know.
So it's weaker on the moon. That's why it can't hold us.
That's right. It's weaker on the moon. So that's why people, if you go on the moon, they kind of float around. They kind of, they're light, right? So our mass is not dependent on gravity. So are we going to weigh the same or different on the Earth compared to the moon?
Different?
What was that?
Would it be different?
Is it dependent on gravity?
No.
No. So in the case, mass is not dependent on gravity. So it's going to be exactly the same. So if we're measuring the mass, let's say we're measuring in grams, we're going to weigh the same amount that we weigh on the moon. So I weigh 100 kilograms on Earth. So I'm going to weigh 100 kilograms on the moon. Does that make sense?
Yes.
That's like not counting the gravity.
Yes, because it's not dependent. Mass is not dependent on gravity.
Okay.
Okay. Where weight is dependent on gravity. So now there's always a tendency of saying weight, how much do you weigh, right? That's our tendency. And when we talk about weight, we're really talking about mass, right? Because we don't have any other reference point other than the Earth, because we're always on the Earth. Does that make sense?
Yes. I think so.
So as I told you, SI unit for mass is going to be kilograms. SI units for distance or length, that's going to be meters. But often when we're talking about smaller distances, we're going to use centimeters and millimeters, or even micrometers if we're talking about really, really small distances. If we're talking about longer distances, we're going to use the kilometer, right? And so that's kind of the beauty of the metric system. You kind of understand because you know what a meter is, and then you know a kilometer is going to be 1,000 times greater. And then we know a centimeter is going to be 100 times less than a meter. Okay. And so often because of that, we will have.
Hello?
Can you hear me?
Yeah, I was having issues with my audio device. What did you say like 30 seconds ago?
I said that if we are measuring distances that are longer, we will use the kilometer. If we're measuring distances that are smaller, we will use centimeters and millimeters.
All right, thank you.
Okay. And because of that, like I said, these are the international system of units, right? Because of that, there's a place where, and usually there's a place in the US, there's a place in France, but the French were the ones that kind of brought everybody together initially to decide, hey, these are going to be the units that we're going to use, right? So in France, they actually keep, in this case is a platinum iridium cylinder in a vault that's kept that measures 1 kilogram. And we know that 1 kilogram is 2.2 pounds. And so that is going to be our system that we're going to use, and everything is going to be set to that standard, right? And so they make replicas and they send it across the world. And so the US has that same replica, and then they use that as our standard in the US. And so when we get scales and everything like that, and we get weights, 1 kilogram weights. So they're used, the standard is used to sit there and to determine whether those weights are accurate or not. So everything has to be calibrated to that system, okay? So we also know that 1 inch is going to be defined as 2.54 centimeters. You guys know that from our measurements of the Mentos lab, right? We did get that conversion.
Mhm.
So we have cubic centimeters, right? We already talked about cubic centimeters being volumes. So the metric for the metric system, or the SI units, liters is the one that we typically use as our base unit, and that's also going to be our SI unit. We also will use the milliliter when we're using smaller volumes, or we can use those cubic centimeters. And so this just gives you an idea of the volume that's going to be occupied by a cubic centimeter. So here, this is 10 centimeters. So this basically is 1,000 millimeters in length. So then this cube here would represent 1,000 cubic centimeters. So we know that 1 cubic centimeter is equal to 1 milliliter, and that's going to be equal to 0.001 liters, or 1,000 times less than a cubic centimeter. I mean, a cubic centimeter is 1,000 times less than a liter. Okay, so here we have the metric system. And so we're able to sit there and do those conversions, right? Because we always know that a kilo of any unit, what it is, it doesn't matter what that unit, that base unit is, a kilo is always going to be 1,000 times greater than that. Okay, so 1 kilo will always be 1,000 times greater. So 1 kilo of that unit is going to be 1,000 times greater. And we can play around with that. We know that a centi unit, or a centi, is going to be 100 times less than that unit. So whatever that unit is, if we have one of those units, a centi-unit is going to be 100 times less than. Okay. So then we can say 100 centi-units will equal one of those units. And then that's the same thing with the milli-unit. Mil is going to be 1,000 times less than that unit. So then if we have one of those units, then a milli-unit is going to be 1,000 times. Okay, questions?
I have a stupid side question.
Yes.
You know how when you do like 1 inch and it's those two little apostrophes, I guess? Is there one for centimeters? Is it the same thing?
No, we just use the cm.
Oh, okay.
That's it. We don't have like the little dot or anything like that. So
Nothing special. Okay.
no, just cm.
Okay.
Okay, so let's do a problem. How many grams are in 0.711 kilograms?
We're allowed to use our notes?
Yes, you can use your notes. So where would I start?
Well, why don't we just multiply by 1,000 since a kilogram is
It's
1,000?
like
So
71.
we would, as you said, we multiply it by 1,000. That's true, right? So you're saying we're starting off with 0.711 kilograms. And we know that 1 kilogram
Is
you said
1,000
was
grams.
1,000 grams. So then our kilograms are going to cancel out. And then we just multiply. Is that right, Jacob?
Yeah.
Okay.
Do that so fast.
Questions, concerns, Cash?
On like the table you do, like what's like an easier like route to like set up the table? You know how
Easy
I
route.
have like it's because
set up-
usually I'll get them flipped around, and does that matter if it's flipped around or
It does. It definitely
does?
does, because you'll end up with the wrong answer. Yeah.
Okay.
So that's
Alright.
actually a good question. Let me tell you how I
Yeah.
remember it. Okay. So how many of you guys have been in a relationship? Anybody been in a relationship? How many of you people have been in a relationship? I shouldn't say guys. How many people have been in a relationship?
I have.
Okay, only one of you guys have been in a relationship. That's hard for me to
I
believe.
raised my hand.
Oh, good. Okay, 2 of you guys have been in a relationship. Okay, so that explains a lot.
I think there's 2 more people missing their hands.
2 more people. Oh, I see. Oh, I see. Yeah, okay. Couple of you guys. Okay. My bad. My bad. I haven't gone down the full list.
I know we're not that lame. God.
Okay. So have you guys ever been in a relationship that you wanted to get out of and you saw somebody else that you want to get with? Anybody been like that?
Yeah.
Yes.
Yes.
Called upgrade.
The upgrade, exactly. Okay, so now when you think about the upgrade, right? Are you going to want to spend more time with the one that you want to get rid of? Or do you want to spend more time with the one that you want to spend the time with, right? The upgrade.
Spend more time with the upgrade.
Okay, because you want to spend up more time with the upgrade, you would consider them to be a priority. You would put them on top of your list. Is that correct?
Yeah, so you got to get rid of the other one because otherwise you're trash.
That's right. So the way we look at it is, or the way I look at it is, kilograms is what I want to get rid of, right? Grams is what I want to get to, right? So then I know that I'm going to put kilograms at the bottom, and then I'm going to put grams on top. Does that make sense?
So what's the box on the left, on the bottom? Nothing?
Nothing. You see that nothing there? Nothing. Yeah, because I always start with my given. Given always starts in that upper corner, right? Because initially they started on top, but you're dumping them for something better, right? So then they get pushed to the bottom. So then you put the conversion of them being on the bottom, and then what you want to get to on top.
So cross them out and just multiply across.
That's right. So this line here, it's good to see faces. I like faces. So weird talking to black screens. So this line right here, right, that basically means multiply. So this is going to be multiplied by this. And then this line here, this line here means divide.
How do we know when we're dividing?
If there's a number underneath here, right? If there's something other than one. One, if you divide anything by one, it's always going to be that number, right?
Yeah.
All right, so then in this case, we're just dividing by one. Sometimes we'll have a number down here that we need to divide by. So this line, it's going to be this times this. If it's this line, then you're going to be dividing by.
Okay.
I'll give you an example here in a second.
Yeah.
Does that help, Jacob?
Yeah, a little bit. It's because I remember on when we did one of the quizzes, when we had to do the 300 centuries,
Mm-hmm.
I had problems on putting which goes where.
Yeah.
Me too.
So if you kind of think about it like that, it'll help you through that process.
Yeah. Okay.
Okay, I want to get rid of this one. Okay, I want to get, it'll help you through the process. Always the one that you want to get rid of is going to be the one on the bottom.
Okay. Thank you.
Okay. So here's an example. So we're going to convert 5.25 times 10 to the 5th milligrams to kilograms. Okay, what do we know? How many milligrams are in a kilogram?
1,000.
Okay, so we know 1,000 milligrams
Oh, is right? Okay, cool.
equals 1 gram. Okay, and then how many grams are in a kilogram?
$100.
No, not 100.
1.
And you said what?
How many grams are in 1 kilogram? Kilo.
Is it 1,000?
It is 1,000. Yes,
Yeah, I was gonna say
Is that
1,000.
like just the 1,000 club?
it's the 1,000 club. That's right. 1,000 grams equal 1 kilogram. Okay, so we're starting off with milligrams, right? mgs. So that's going to be our given. So this here is our given. Okay, now we want to get rid of milligrams, right? So this one converts milligrams to grams, right? And we ultimately want to get to kilograms. So our goal is to get to kilograms. Okay,
So we put a kilogram on the bottom, right?
no, because we want kilograms.
No, it'll be
Kilograms is
it'll
what
be
we want.
Milligrams, right?
What was that? Say it again,
It'll be,
Jacob.
it'll be a milligrams.
Yes, we're going to put milligrams.
1,000,
on.
right?
That's right. So we're going to put 1,000 milligrams on the bottom because we want to get rid of it, right? We want to get rid of the deadbeat.
And then the 1,000 milligrams on top is gonna be 1 gram.
We're going to have 1 gram initially. That's right. Because that's the conversion that we have. Right? So then that allows us to get rid of the milligrams. And then here we want kilograms. So who's going to go on top? Kilograms or grams?
In the kilograms.
So here I'm going to have kilograms on top because that's what I want. That's our priority.
And
So
1
then I'm going to
kilogram
have,
is 1,000 grams.
Okay, so then we
Wait, Bob, I'm in
multiply
class.
across. So this is just multiplied by 1, and then we divide it by 1,000, and then we divide it by 1,000 again.
It's not gonna end until 9:50. So would it be easier?
So here, because the top is going to be multiplied, so you have the 5.25 times 10 to the 5th multiplied by 1 times 1, right? Because these lines here represent multiplication. And then this here, this line represents division. So we're going to divide it by 1,000. Then we're going to divide it by 1,000 again.
Okay.
Okay. So then we end up with
0.525 kilograms.
That's right. Okay, questions?
Yeah, one quick question.
Okay.
How did you do the 10 to the 5th on the calculator again?
Let's see if I can do this. Hold on 1 second.
Okay.
It looks like a little arrow pointing up.
Arrow pointing up. On this calculator?
No, use the EE sign.
Oh. Did I push EE and then 10 or 10 and then EE?
No, you don't need 10. The EE represents that 10.
Oh.
So all you have to do is put the number next to it. So you put EE and then the number that, so it'll be 5, right?
Oh, and then we divided it by 1,000.
Yeah.
And then divided, oh, okay. Okay, thank you.
You're welcome. Okay, questions? Any other questions? Okay, good. Okay, so let's say we're doing another conversion here. A fruit drink is sold in bottles that contain 1,892 milliliters. Express the volume in cubic centimeters and in liters. So what is our given here?
By the way, Dr. Henry, can I ask?
Yeah.
The slides you use for the recordings, they are all in like the file sections on Canvas, right?
Yes.
And in
All right,
your
thank
note
you.
packet.
And they're also the packet that I hand out. Yes.
Well, I mean, I don't think I got one if you gave it to us on Wednesday.
No, I gave it to you 2 weeks ago. Or
No, remember my side of the table didn't get
oh yeah,
them.
yeah, that's true.
We
You're
ran
right.
out, so he probably doesn't have one.
No, but then he printed out more.
Then you should have it.
Okay, yeah. All right. I'll be
Okay,
back.
so the given is 1,892 milliliters,
Okay.
right?
Yes. Okay, what is our goal? What do we want to get to?
Cubic centimeters.
Okay, so we want to
Wait,
get to
and
cubic
liters?
centimeters.
So we want cc's and liters?
Yeah, so we're going to do it independently, right? We're going to do
Okay.
cubic centimeters first, and then we're going to do liters.
Okay, so it has to be 2 answers.
That's right.
Okay.
Okay, so what is the conversion for cubic centimeters to milliliters? Sonia, No, it's not 1,000. Sonia, are you there?
Oh, yes. Sorry, I couldn't unmute it.
Okay.
1,000 milliliters.
No, it's not 1,000 milliliters.
1 liter.
You said 1. So 1 cubic centimeter is going to equal 1 milliliter. Is that correct?
Ah.
Okay. So it's a 1-1 ratio. So then our answer is just going to be,
It's upside down.
oh, sorry. Thank you. Good eye. I was testing you. So then our units cancel out and we end up with centimeters. Same answer. Okay, what about liters? What is the conversion of milliliters to a liter? Mil.
1,000 milliliters equals 1 liter.
Okay, so then is 1,000 going to go on top or is it going to go on bottom?
The top? No, wait, you want it to cross
The
out?
bottom. The milliliters go on the bottom, right? Yeah.
Yep. So the 1,000 would go on the bottom
Ooh, she's so
because
smart.
you want it to cancel out. You want to get rid of the deadbeat and get to the new guy.
Okay, that helps more.
Okay, questions? Concerns?
Okay. You wouldn't,
Cash?
I have a question.
Yes,
So you wouldn't divide by the 1,000 or you did?
we did divide by the 1,000.
I see you multiplied across and then divided that.
That's right.
Oh,
That's how I ended up with 1.892.
oh, okay, I didn't see the dot. Or point, whatever, okay.
I'll work on my dots.
I'm not wearing my glasses, so it's fine.
Okay. Okay, questions? No questions? Good. Okay, now we get to talk about sig figs. Okay, so when we talk about significant figures, the best way of doing this, let me show you. It's a lot easier. So we're gonna skip this. We're gonna move to something else real quick, or we're gonna move to a whiteboard. Give me 1 second. If I can remember how to do it. Okay, do you guys see my whiteboard?
Not yet. Oh, yeah.
Yeah, yeah.
Good. So, you still see it?
Mhm.
Okay, so did I tell you guys about my Tinder experience?
Yeah.
I shared my Tinder experience with you guys.
Too
No.
much. Too much.
No, I didn't share that with you guys.
No, you didn't, but you should.
Okay, so let me share my Tinder experience.
Give us the choose me.
Okay, so my girlfriend doesn't like this, but you know, I've been on Tinder and everything like that. And I decided I wanted to try to get a very smart woman, right? Somebody who's, you know, scientifically inclined and that can do conversions, right? So I was typing up my Tinder ad, right? And you know how on Tinder you give them your weight and all of that stuff. I told them I weighed 100, right? Now, I do weigh 100. I weigh 100 what?
Kilograms?
I weigh 100 kilograms. Okay, but I forgot the kilograms, right? So how many of you guys would date a guy who weighed 100? Or how many of you people would date a guy who weighed 100?
I think
Michael,
my
would you date a
guy's
guy
like
who weighed
200
100?
kilograms.
What was that?
I said, I think my guy's like over 100 kilograms, so you're good.
You think over 100, but 100 pounds, because I didn't put kilograms, and we
Oh,
are in
100
US.
pounds? That's a child, so no.
Alyssa, would you date a guy who weighed 100?
Yeah.
Yeah, you would? Okay.
High five to you, girlfriend.
So you like him skinny, is that what you're saying?
Yeah.
Okay, well, hey, each to each his own, So I know that if I ever I noticed I didn't get any hits, my girlfriend was pretty happy about that. But so the point is that when I used that, I had to use units, right? I neglected to use units. So in the US, most of us would think that we're talking about pounds. Somebody who weighed 100 pounds is often considered to be anorexic, especially if they're like 5'8", 5'9",
Mm-hmm.
Wouldn't you guys agree with that? Michael, would you date a
Some
guy
sort
that
of health
weighed,
disorder.
what was that?
Some sort of health issue.
Yeah, some sort of health issue, that's true.
Chronically
Michael,
ill.
would you date a guy that weighed 100 pounds?
He would.
No.
No.
I'm definitely not a guy.
Hey, Kai, that is cap.
Okay. So, hey, like I said, the whole point is that you probably wouldn't, even if you weren't into guys. I mean, if you were into guys, right? Because they're often a little too thin. You think they have some type of health issue.
So fly away in the wind.
Okay, so, but we understand that we always have to use units, right? So the next thing that I want to talk about is uncertainty. Let's say we're using those 100 kilograms, right? And so my scale at home gives me 100 kilograms for one reading. The next time I use my scale, it gives me 105 kilograms. The next time I use my scale, it gives me 103 kilograms. The next time I use my scale, it gives me 102 kilograms.
All right, I'm back.
The next time I use my scale, I get 103 kilograms. So if you're looking at my scale, this here is the 10th spot. I mean, this is the 100 spot, this is the 10th spot, and this is the 1 spot. Where is the uncertainty? If I
In
got
the
on my
one
scale,
spot?
in the 1 spot, that is correct. So we know that the 1 spot has uncertainty associated with it. My scale is cheap. I got it at the flea market, right? There aren't too many scales that. Oh, go ahead.
Oh, yeah.
No, go
Yeah,
ahead.
because 2 kilograms is a big difference.
Yeah.
5 kilograms is a big difference.
So you're saying my scale is really crappy? Is that what you're telling me?
Yes.
Okay.
So
So
no
my
way it
scale
fixes
is huge. It's really, really crappy, right?
Yep.
So, but based upon this, right? Based upon this data, since I have uncertainty associated with that number, but I'm sure about these 2 numbers, right? I can sit there and say, well, because it's not greater than 5, they were all less than 5, were they not?
Yes.
I can say that I weighed 100 kilograms. And I'll put a bar over that other O, right? Now, the bar represents that I'm certain about that 0, okay? So we're going to be talking about sig figs, significant figures. Type that on the board. Oh, actually, it's right up here in the title. Significant figures. And so often I use the abbreviation. Actually, I don't have it on here. Bless you. Significant figures. So sig figs is the abbreviation that I typically use, right? To stand for significant figures. Significant figures are the figures that we're certain about. So we're certain about this 1 and we're certain about that 0, but we're uncertain about this other 0. Okay, so this 0 here is uncertain. based upon my scale. Okay, so we're uncertain about that digit. Okay, so a lot of times what we would do is we would put plus or minus. So we'd put plus or minus what, 5 to sit there and say it's 105 or 100 plus or minus 5. So that would be one way of dealing with the uncertainty. The other way is just to kind of calculate it into our number. By putting that 0 there, we're saying that we're not sure about that, right? Now, let me give you guys a little more information. So if I have a 0 between two non-zero numbers, you guys see the 0 between two non-zero numbers in 101, right? This here is called a captive 0.
Recording in progress.
Okay, so this 0 here is called a captive 0. Now, captive zeros are going to be significant because they're between two non-zero numbers. Okay, these zeros here, these are called lagging zeros. Lagging zeros are space holders. They're not considered to be significant. They're just there to let us know that we have a large number. We have 100. We don't have 1. I'm going to go ahead and erase this. So these guys are called leading zeros. Kind of like those lagging zeros. These guys are not going to be significant either. They're just space holders. Okay, questions? Okay, so now when we want to say a 0 is significant, we take the extra time to put a decimal point. So now this means that I have 3 significant figures because I took that extra time to put that decimal. So this guy would have 3 sig figs. If I take the extra time to put zeros after the decimal point, that says that I am sure about this. It's not uncertain. So I'm taking this extra time because I'm a lazy person to put these extra zeros here, right? That you would normally not use for anything else. So then that means that I'm telling you that these are significant. They're important. So in this case, I would have 5 sig figs. Okay, questions? Good, okay. That means we can move on. Nobody has questions. Okay, so I'm going to put a couple numbers up. I want you to tell me how many significant figures I have. Okay. So say A, B, C, D, and E. Mr. Perez, are you there?
Mr. Perez. His mic
James.
doesn't work.
That's all right. We can make it work still. He can type in the answer. He can help us out. Okay, so, and the very first one, how many sig figs do we have there, Mr. Perez? Okay.
I get
He
it wrong.
says 2. Do you guys agree?
No.
Thought it was 5. Thought it was the whole thing.
So
There aren't any decimals on there.
there aren't any decimals on there. So then how many sig figs should I have?
None.
1.
1.
I should have 1 because I have one non-zero number. So number of sig figs, I'm gonna put that over here in orange.
Well, then I got all of it wrong. Hold on.
Okay,
What
we
was
have
the reason
1.
we got 1?
Repeat that, please.
What was the reason we got 1?
Because we're unsure about this because we didn't put a decimal point here, right? So these guys, we have uncertainty about these numbers, right? So really this could be, we could have 19,899, or we could have 21,000. We don't know. Because this 0 we're unsure about, that makes all of these other zeros we're also unsure about. Okay,
You
so
just
that
put
means
1?
that the only thing that we know here, because there's not a decimal point saying that we're sure about it, right, is that 2. So that means that the only significant figure is that 2.
Okay, so would we put like plus or like adding and subtracting?
We'll
Like we
talk
did
about
on the
addition and
100?
subtraction in a second. First thing we need to be
Okay.
able to do, first thing that we need to be able to do is identify the number of significant figures, right?
Okay.
Which figures are we absolutely sure about? In this case, we're only sure about that 2 because it's a non-zero number. So those zeros, we're not 100% sure about.
Would B be 2?
So no, B would be 3.
3.
3. Oh, okay. Never mind.
Because remember, the captive
Yeah.
0 becomes significant because it's stuck between 2 zeros.
Yeah.
So we're
And
sure
then it
about
makes
that.
it, and it makes it a captive, right?
That's right.
Okay.
Okay. What about C?
6?
That's right. It's 6 because we took the time to put the decimal there. And then we're saying we're putting 2 other zeros following it to let us know, hey, I'm sure about these. So that's 6. What about D?
4.
6.
I put 6.
It's also 6. That's correct. Because again, we have the decimal here. And then we took the extra time to add on those zeros. Because really, if you're lazy, you're not going to put any extra time unless it means something, right?
So since there's a decimal, those numbers are significant, all of them?
That's correct. Yes. So what about here?
Would it be different if those are the leading zeros?
It is different when they're the leading
So it'd be
zeros.
3?
That's correct. That's right. It's 3.
3.
Yep. Because here we have to put these zeros because it's such a small number. So these zeros are just placeholders.
Oh, shit.
Okay. So otherwise we wouldn't get that number. We need those zeros there to hold that spot, but they're not significant. Okay, are you guys with me?
Yes.
Good. Want to try a couple more or do you guys got it?
A couple
Wait,
more,
can
please?
you repeat the last one?
Okay, I said it's 3 because it's just these 3 because these zeros in front, these leading zeros, they're just placeholders. They're letting us know that we have such a small number right? Because we know that this is a really small number, 0.003, that's a small number, right? We need these zeros to let us know that they're small numbers, but they're not significant. They're just holding that space so that we know that it's a small number. Kind of like these zeros here, up here. These zeros are also space holders. They let us know that we have a really large number. Does that make sense?
Yes.
But for D, like it's the zeros, like the last two zeros, they cannot be different.
So those are different because we have a decimal point there, right? So like when you're writing a number down, right? Do you write down 1.3000, or do you just write down 1.3?
Yeah, I just put 1.3
Why?
because you round it.
Because
round
the
it.
zeros don't make a difference.
Because those zeros don't make a difference, right? So if we take the extra time to say that these zeros are there, we're telling the other people that we're sending this data to that, hey, these are important because I'm sure about these. I know that these are really zeros here, right? Because you took that extra time to put them down, that means you're sure about them, right? If you didn't take the extra time to put it down and you just put 1.3, then you only have two significant figures. Where you're taking this extra time, you're saying, these are kind of important. I want you to know that these zeros are important and they're really zeros. They're not fake zeros, they're real zeros. Does that
That's
make sense?
1.35.
Yeah, because we took that extra time to sit there and write them down.
All right.
Okay. So another. Okay, so that first one, how many sig figs do I have?
3.
Everybody agree? Anybody disagree? So that means that everybody agrees.
4.
So where are you getting 4 from? So what would be the significant figures? Drawing on my screen.
Well, I can't draw it, but because it isn't the first one a captive zero?
So this is a 0. Yeah, that's a captive 0. So that's 1, 2, 3.
But because there's a number after it, it's a significant figure.
Which one?
2.
The 2.
The 2. So that's 1, 2, 3. So we have 3 sig figs. That's correct.
Okay.
So, but is there 4 sig figs? Or is there 3 sig figs?
There's 3.
There's 3. Yeah.
Because there's no decimal, so those zeros don't.
That's right. These zeros are just space holders. They're letting us know that we have a large number.
Okay.
Okay.
So usually if the zero is captive, the 2 on the outside of the 0 are significant?
No, so if the 0, okay, wait. So non-numerical numbers, non-zero numbers are always going to be significant, right?
Okay.
So if it's a non-zero number, it's going to be significant. If you have a 0 between a non-zero number, right? So like this, a captive 0, that's going to become significant, right? Now here, these guys, these zeros here that I'm going to circle in green.
And they don't matter.
They matter. They're space holders, but they're not significant, right?
Oh,
so
okay.
in other words, there's uncertainty associated with it. Okay, so we're not sure that these are really zeros. Really, this could be a 1, right? Or it could be a 2 or a 3.
Okay.
We don't know.
Yeah.
Or this could be a 0, that could be a 1, that could be a 2, right? We don't know. So we're just guesstimating. We're saying, okay, it's close to this number. kind of like we were talking about my weight. I said I was 100 kilograms, right?
Yeah.
Where I really could have been 105 or 102 or.
Yeah.
Okay. So now what about this second one?
5.
5.
5.
Okay.
That is correct. Because we know that all of these, because of that decimal point, are going to become significant.
And the next one's 6.
The next one is 6.
And the last one's 1.
That's right. And the last one is 1. Good job.
Good job, Jacob.
Thank you. Thank you.
Okay, you guys got it? I know Jacob got it. Anybody else? Everybody else got it? Juan?
But
Can you explain the last one?
I almost put 3 for the second one, but I was like, it's 3 or 5.
Can we go over the last one you said?
yeah,
Yes.
Okay, so here we have one non-zero number, the 1, right? All the other ones are zeros. There's not a decimal point there, right? So these zeros here that we're putting down here is just to let us know that we have 10,000. Because if we didn't put those zeros down, it would just be 1. And you would be really pissed off if you've earned $10,000 and I paid you $1. Wouldn't you be upset?
Yeah.
Yeah. So these guys, although they're not significant, they hold a spot to let us know that we have a large number.
Okay.
Okay. I tried that with Angelia, you know, I owed her $100 and I tried to give her $1. She didn't take that.
That's how you end up on Snaps, man.
Okay, questions, concerns, Cash? Okay, good. Okay, so somebody was talking to me about addition. So what happens when we're adding, right? So when we're adding, we have to sit there and line things up. So we need to get an idea of how many, well, where significant begins and where significant ends. Okay, so let me give you an example. Let me pull up my example. Slides. I may be able to pull up example. I can find my. Oops. Okay, so in the case of addition and subtraction, what you're going to do is you're going to draw the line between where uncertainty begins, where you have certainty and when uncertainty begins. So like for instance, if we take a look at this number, how many sig figs do we have in that very first number? This one
4.
right here. We have 4, right? So uncertainty will begin right after the 2. So we're going to draw a line right there.
Because we know all zeros add up to 0.
Well, no, it's because we know that for that number, that 0 is uncertain, right? So it's that uncertain part. Now for the next number, uncertainty also begins right there, right? The same spot. So we draw that line at the same spot. Okay, now the third number, where does uncertainty begin?
Space over to the left. There's
1, 2.
after the 2.
After the 2. So we're going to draw the line there. Okay, and then the last number, we know it's right after the 1, right? The same spot as before. So in this case, we're going to go to the one that's furthest to the left, the line that's furthest to the left, and that's going to be the green line. Do you guys see that?
Yes.
Okay, so that's going to be the line that we're going to choose because we're looking at the place that has the most uncertainty. And so 12,000 has the most uncertainty associated with it. Okay. So
Okay.
then we're just going to add them up. So if we add these up, it's going to be 0, 6, 3, 2, 3. Okay. So we go to that line, the number right following that line is a 3. If that number is greater than 5, we're going to round this 2 up to a 3. If that number is less than 5, we're going to leave that 2 alone and just put zeros here, right? Because that means it's uncertain. If it's right at 5 exactly, then we were also going to leave this 2 alone and then just put zeros there. Okay.
Put zeros for 360.
So no. So what I'm saying is that since this is a 3, is that greater than 5 or less than 5?
Less.
It's less than 5. So then my answer is going to be 32,000.
But if it was greater than 5, would it be 33,000?
If it was greater than 5, then it would be 33,000.
Okay, thank you.
Oh, so you're just rounding it to the, what's it called? What's that thing called? I don't remember. It's rounding something though.
Right. So we're rounding it up to the significant figure. So we're sure about that too, right? And then the question is that number, if that number is greater than 5, then it's really going to be closer to 3 than it is, right?
Okay, so it's like how you didn't know your weight. It was kind of over.
Exactly.
So you just round it to, okay.
Exactly. Yes. And so in this case, it's the same concept, but we know that there's a lot of uncertainty associated with this 12,000. So we know that we can't rely on these zeros really being zeros. So we're taking into account that uncertainty. So then we just do the addition, and then based upon what we added up to, then we round up or we'll leave it alone. So in this case, we left it alone. So that's 32,000. And these guys become zeros because they're uncertain. Does that make sense?
Yes.
Okay, so let's do this next one over here. This one here. Okay, so where does uncertainty start in this case?
Wait, uncertainty?
Uncertainty.
The first zero?
No.
Would it be at the 1?
It would be after the
on the left.
Yes.
Oh, on the right.
On the right of the 1.
Okay.
Okay, so here, this is where uncertainty would start for us. Okay, for the first number. Okay, now for the second number, that's going to be in purple. It's also going to be at exactly the same spot, right? Right after that 1, because there's nothing there, right? The third number.
The 1?
It's going to be after the 1.
And then the last one's after the 3.
And then the last one would be after the 3.
Okay.
I forgot, but Dr. Henry, what are significant figures used for again?
Uncertainty.
No, but like what their use cases?
Uncertainty. In measurements and calculations, they're used for uncertainty.
Margin
like
of
how
error?
When
earlier
we're not
he said,
sure.
So
about
is this like the margin of error?
Yeah, it's sort of like the margin of error in a sense, but you're incorporating it in the number itself.
All right. Thank you.
Okay, so we take the green line. So go ahead and do the addition. So if we do the addition, what do we end up with? 2, come on. 2, 1, 5, 6, 1, 0, point, and there's a 1. Okay. Okay, so which number are we going to use to determine whether we're rounding?
That the 5?
The 5. So the 5 is what we're going to use. So now the question is it greater than 5? Is it
No,
less
it's equal,
than
so
5?
you're gonna let it be.
Are you sure?
Can you remind me why we're doing it where the 5 is?
Because this here, the most uncertain number that we have here is the one in green.
Okay.
Right? So we drew the line of uncertainty right there. So we have to take that number. That's going to be the point where we decide where we're going to round at. Because that's where uncertainty begins for that number. All the other ones are more certain. They're more exact, right? This one is the least exact. So you have to take the number that you have the least exactness for and use that one, because that's the one that's going to give you the worst values. Because we don't know as much about that one as we know about the others.
Okay.
Okay,
But since it's exactly at the 5, it's going to go down?
Okay, so you guys are saying that it's exactly at the 5. So I'm going to ask you a question. If I have 5.1, is that greater than just 5?
Yeah.
Barely, but yes.
Okay, but it is greater, right?
Yeah.
Okay, so we'll put it like this. If somebody was going to give you a 5.1% raise, would you say, no, just make it 5?
No.
No, right? Because we know that that's greater than 5, right?
Yes.
So in this case, we have 5, 1, 2. Would that be greater than 5?
Yeah.
Okay, so then what am I going to do in that case?
Oh, so it would be 1.
You're going to round up.
I'm going to round up.
Earlier you said if it was at 5, then it would go down.
I said if it was exactly at 5.
So
if there was no 1, 2, that would be exactly at 5?
That would be exactly at 5.
Oh. Okay, got it.
So my answer should be 1.017. Okay, because it's greater than 5. That number is technically greater than 5. It's 5 point something, right?
So if it's greater than 5, you don't have to add the zeros?
Yeah, so if it's greater than 5, well, you don't have to add the zeros anyway, because now if we add the zeros, that means that they're significant, right?
Okay.
So you don't want to add the zeros in this case.
There's a decimal.
Yes, because there's that decimal.
Okay, all right.
Okay.
But so let's just say if there was no decimal, and let's say if it was the problem like on the left.
Yeah.
Without a decimal, but if there, since there's no decimal here, would we add the zeros on that one?
Yes, because then they're space holders, right? Because they're making that value, right?
That's right. That's right. Okay.
Okay. It's kind of like, okay, so it's kind of like, again, if I owe you, $10,000, right? And I give you a 1, is that the same? Is 1 the same thing as 10,000?
No.
No, it's not. So the difference between 1 and 10,000 are a bunch of zeros, right? Those are space holders. They're taking up that space. They're letting us know that that is a bigger value than just 1, right?
Yeah.
Usually we do this in class and I earn about $20, because people don't get it. And I say, put your money on the table. I give them a $1 bill for their $10. You guys are really ripping me out of my money here. Don't get sick.
$20 in ramen noodles.
What was that?
$20 in ramen noodles.
Oh, okay. Hey, I'll take it. I love ramen noodles. Okay, so let's go ahead and do subtraction. Subtraction is going to be exactly the same way. So in this case, the very first number here, right here, where does significance end?
2.
After the 2. Which 2? The first 2 or the second?
Right 2. The one after the 1.
Okay. Okay. And then the second number, where does significant ends?
The second 2.
After the 2?
The first 2, technically, I guess.
Okay. So let's go ahead and do the math.
So 0 to.
Oh, shit.
Oh my gosh, I did it wrong.
I started adding. Did you start adding?
No, because if it's a 12, that's greater than, no? It's greater than 5?
What was that? Now look at it. You're only looking at this number here. You're only looking at the 1.
Oh, okay. So I was right.
Okay. So then what should be my answer?
8,800.
How did you get 8,800?
So I'm bad at math. Hold on.
No, it'll just be 8,000.
Should be
Hold on,
8,000.
hold on. I think I did it wrong. Hold on.
And so how many sig figs does my answer have?
1.
1 sig fig. That is correct. Okay. Questions? Okay, let's do this last one. Okay, so where does significance end?
After the 3.
After the 3.
After the 1.
And then after the 1. And Jacob, I think it's just me, you, and
You forgot my name, didn't you?
oh wait, give me a second. Give me a second.
You're looking at the screen. That does not count.
It's right there.
Well,
Hold
it's
up.
not. It's not at the top of my screen. My screen is all screwed up right now.
I have a question though.
Yep.
For the last one,
Her name is Miranda.
It's not Miranda.
Gabe, I'm gonna punch you in the snout. Anyways, for the rounding part,
Yep.
you said it's the number. Okay, so it stops at 2. So then you go to the number that comes at the 0, or 2 numbers over. Okay, wait, hold on a minute. Okay. So, okay, it stops at the 2, and then you got a 1 right there, and then you look at the number next to that.
Okay, so because it stops at the 2, right? We drew the line. You see where the red line's at.
Yeah.
Right? And so you always go to the right-hand side of the red line, right?
Which
of
is
that
1.
line, of the front line, right?
Okay.
And so you use that number to decide whether you're going to round up or you're going to leave it alone. If it's greater than 5, we round up, right? If
Okay.
it's exactly at 5, then we have to look. If there's numbers following it, that means we round up. If there are no numbers following it, they're all zeros, then we leave it alone, right?
Oh, so since it's a 1, just forget those numbers and a 0?
That's right.
Okay.
Because it's closer to 0 than it is closer to it being 9,000.
Okay.
Okay.
Okay. Thank you.
Okay, so if we're going to go ahead and do this, so let's go ahead and do the math.
So if the number drops, we don't have to put the 0, right?
If the number drops, we don't have to put the 0. Okay, so then
0.994? Or would it be 0.993?
okay, so we have 0.9943, right? So
Yeah.
which number are we going to use to determine whether we're rounding or we're going to leave it
The
alone?
3.
The 3. Okay. So what are we going to do?
So it can't go up.
0.
0.9940.
0.99. Will we put a 0? Because if we put a
Wouldn't it just go
0,
down 1?
no, we would leave it alone, right? So either you're going to round it up or you're going to leave it alone.
Oh, okay.
Okay. So in that
What is
case, we look at this 3, we're not going to put a 0 because then we're adding another number of significance. We don't have that other number of significance. We just said that this was uncertain. This 3 here is really uncertain.
Okay.
Otherwise, we'd be using it.
So would the 4
So wouldn't it be
technically
9,000?
uncertain too?
What was that? Okay.
Go ahead.
I said, so, fuck. The 4 is technically uncertain too, right?
No, the 4 is certain. We're sure about the 4 because we had non-zeros here.
Oh,
We're
okay.
certain about that 3, right? Because here We don't know what's here following it, right? And after that 1, right? So we have 0.11.
I don't have money. I'll give you a car though.
Okay,
have
so
0.
you're either rounding up or leaving it alone.
That's right.
Okay. Okay, I think I get it now.
Okay. So in this case, we're not going to add that 0, right? Because again, we just determined that we're not sure about it. So if we put that 0 there, we're saying we're sure about it. Does that make sense?
Yeah.
So then we have 3 sig figs. Now somebody else was saying something.
I think Sarah was saying something.
No. Yeah, I was thinking it would be 9,000, but never mind.
Okay, you saw that there's decimal points there?
Yeah.
Okay, good. Okay, now that's addition and subtraction. Now, when we talk about multiplication and division are going to be a little bit different, right? In the case of multiplication and division, you just want to go with the one that has the least number of significant figures. That's going to determine our number of significant figures per answer. Okay.
Is that one going to be harder?
What was that?
Is that one going to be more challenging?
No, it's easier.
Or is it easier?
Let me clear. Hold on. Oh, I'm sorry. Okay. So this first number, how many sig figs do we have?
1.
We have
4.
1. Good job.
Wait, so it's 1?
Yep, there's 1 here, right? The second number, how many sig figs do we have?
3.
3, that's correct. We have 3.
I get it now.
Okay, so if we multiply this times this, what do you guys end up with normally?
1 times.
We have
20.
0.001 times 2020.
2.02.
Yeah.
2.02. Okay, so we're supposed to have 1 significant figure, right? So we take a look at this number here. Are we going to round up or are we going to leave it alone?
Leave it alone.
We're going to leave it alone. So then we're going to just end up with 1 significant figure. Our answer is going to be 2.
Oh.
That's it. Because we only want 1 sig fig.
When we do this on a test, are we going to be allowed to use calculators?
Yes.
Sweet. Okay.
Okay. So if we do division, it works exactly the same way. So this first number, how many sig figs do I have for the first number?
4.
I have 4. And then what about the second number?
3.
I have 3. So which one is less?
3.
3. Okay, so if we do the multiplication, the division, we end up with
23,150.
okay, and then how many sig figs should we have?
3.
We should have 3. So then my answer should be
232.
232. Are you sure?
Well, are we gonna round the 1? I'm so
Yes.
I'm kind of confused. Can you go back? After
did
you
we do,
divided
100?
it, what did you say?
I said after we divided it, right? This is the number that we get, right?
Yes.
Okay.
Yeah.
Now how many sig figs should we have?
3.
We should have 3. So we're
3
going to go.
because of the 10?
Yes, because the 10 has 3. This one
Okay.
has 4. So we go with the one that has the least number, right?
Okay.
3 is smaller than 4, right?
Okay.
Okay, so then we go over, that's 1, 2, 3. Okay, so then we take the number after our 3 sig figs. We use that number to decide whether we're going to round or leave it alone. What is the rule?
If it's greater than 5, then you round up.
If it's greater than 5, then we round up. Is it greater than 5?
Yes.
No.
No.
Yeah.
Is it greater than 5?
Yeah.
No.
Oh,
Is 5 greater than 5?
oh no.
Equal to.
No.
It's equal.
Is there a number following it?
Oh, so it's 50. So yeah, it is greater than 5.
No, no, no. Is this 5 here greater than 5, right?
But
You're just
it's
looking
5.
at you're looking at this number alone, right?
5
Or
is
if you're
equal to
looking at-
5.
Wait, it's a 5, right? It's
Yes.
right at 5. Is it greater than 5? Is
Nope.
5 greater than 5? Or is it equal
No.
to 5?
It's equal to 5.
It's equal to 5. Is there any numbers following it?
No.
0.
There's no numbers. The 0 doesn't count as a number, right? A non-zero number, I should say.
All right.
Is there a non-zero number following it?
No.
No. So then it's exactly 5, right? So what is the rule if it was exactly 5?
You don't round.
You don't
Let
Let
round.
it be.
So then my answer should be,
23.
what?
231.
is it
That would be-
231?
Oh my, I am so
Something?
lost. I don't know.
Would you just leave the 0 there then? Because if you take that 0 off, it's going to change the whole number.
Exactly. So you need the zeros as placeholders. Thank you. That's what we're getting at. So it'll be
Oh,
20,
and there's like
it would be 23,100. Because you're saying these zeros are now letting us know that there was uncertainty. Because we're not putting a decimal point, right? We still need those zeros to make it 23,000.
Why'd you take the 5 away?
Yeah.
I thought you
we
said
can
we're
take
supposed
the
to leave
5.
it alone.
Yeah, we're leaving alone. We're leaving the rest of the numbers alone. We're leaving the next number alone. Did we raise it up?
Oh, you're leaving that number alone, changing the rest of
Exactly.
it. Okay.
So you're using this number here, the one that we have underlined, right? We're
To
using that
determine the
number
one.
to determine whether we're going to round up the number in front of it. Or
Okay,
we're
I
going to leave that number alone and then put zeros following it.
My bad.
Hey, Dr. Henry.
Because again, you guys need to remember, again, it's the space holders, right? So $23 is not the same thing as 23,000, is it?
No.
I got confused because
Oh, I didn't
when
hear what you said.
can you hear me?
Yeah, I can hear you.
When I got confused when you counted the 3 significant figures, I counted all the way to 5. So I was looking at the 0 to go up for the 5. Or
Okay.
like go down or leave it alone. So I thought the 5 was gonna stay there. But
No.
it's the 5 that we're looking at. So
That's right, because that's 1, 2, 3, right? 3 sig figs. So then we're using that 5 to determine what we're going to do with that 1.
that makes
Does
more
that make sense?
Yeah.
I have a question.
Yeah.
Okay, so if we're doing it based on which number has the least amount of significant figures, why don't we just stop at 231?
Because the value of it is at 231. So if I owed you $23,000, you would accept 231?
No,
Are they the same value?
no.
They're not, right? So you still want to be in the same ballpark, right? It's okay if I'm off by a little bit, like $1 or $2 or 100 or 2, right? But I'm off by a whole 1,000, you know, a factor of 10. You would be a little upset, wouldn't you?
Of course, yeah.
Yeah.
Got
so
ripped
these
off a
numbers-
whole 100%.
Yeah, $231 is nowhere near 23,000,
Yes, yeah.
right? So if you think that, you can come work for me and I'll just pay you $2, right? Instead of paying you $200,
Dude, inmates make more money than that.
right? So
Hey, Dr. Henry.
again, you got to remember that you need those zeros are space holders, right? They let us know the value of things, right? So that's what those zeros are for. They're still letting us know the values. They're important, but they're not significant. Do you understand? There's still uncertainty associated with it.
Hmm.
So you guys are getting hung up on the value, right? Because we're not changing the value. We're changing the uncertainty of it, right? Because we're saying, because this guy has more uncertainty associated with it, we have to use that one to sit there and determine the certainty, even though the other one has more precision to it. It's a better number, right? So the way I like to look at it is, because remember when I talked to you about my scale, right? My scale was crappy. I believe Adelaide, was it Adelaide? Adelaide?
Yes.
So you're the one that you mentioned about in Mexico, right?
Mm-hmm.
And so, and you were telling me my scale was like, I told you it was 5 kilograms off, right? So that's
Yes,
a lot,
that's-
right?
Yes.
So you would say that that's a shitty scale because it's so
Yes.
fluctuable, right? So what you guys have to realize is that we don't all have great equipment. Sometimes we have really crappy equipment and we're going to be sharing data with other people. So when we share data with other people, right, they have to take in consideration how accurate our instrument is, right? And the way that you're doing that is by adding that aspect of uncertainty, by putting those zeros there and saying that these are the only numbers that are significant. So when you're sharing the data, when you're writing stuff in charts, if you're not putting those decimal points there, you're saying that you're not sure about what's following them, right? So if you tell me somebody weighs 230 pounds, right? And you just write 230, so that tells me that you're not really sure about that 30, right? It could be 32, it could be 35, it could be 31, but you're kind of close. You're pretty sure that it's close to 230, but you're not 100% sure on that. If you took the time to put a decimal there, you're letting me know that, yes, I am sure about this. Does that make sense?
Yeah.
And so when you're doing the calculations, you also have to take into consideration that uncertainty, right? So let me give you a real life example. So I was working on a project. I used to work with HIV. We used to monitor patients that would become drug resistant to certain drugs. And so there's this new drug that they had developed, and they had done the study, and they didn't do enough patients. And so they start discovering after 10 months, the patients would start to develop drug resistance to the drug, this new drug, in the trials that they were doing. And what they had done, they took samples that were from Uganda, they took samples that were from Switzerland, they took samples that were from, where was it? I think it was Scotland. Okay, so they were taking these different populations and samples from them. Now, in different populations, they have different instruments. Their instruments are not equal in a lot of ways. And so the person that was doing the calculations didn't do significant figures initially, right? And so when they determined the scale that they were using, they had used the numbers and they didn't use sig figs. And they didn't take into account that in the case of Uganda, the equipment that they were using was very sensitive to heat. And so it would always be off by a whole lot. And so when they took those values, they just took them as face values and they used what it was. And then they determined, okay, so this is going to be the range of drug that we should be giving these patients, right? So after 10 months of getting drug resistance, that's horrible, right? And so they kept seeing this and they thought, well, you know, maybe it's just because it's in Uganda, but they start seeing it that it was happening everywhere, right? And so what they figured out was that the person who had done the calculations didn't take into account the uncertainty that was associated with it. So they sent us the samples, right? And then this time we did a huge amount of data, right? We took patients from all over the place, a big pool. And then I actually took into consideration, because I was taught, you should always take in consideration that uncertainty. So I wrote down how they were all writing their numbers and everything like that. I took it into consideration. I contacted them to make sure that I understood the instruments that they were using and some of the issues that were associated with it. And I factored that into it, right? So my numbers were significantly different than what they originally wrote, right? And so they did the study again, and they've been doing the study, and now it's been, what, 25 years or so, something along those lines. So 25 years they've been doing the study, and they've just did a retake of the study using the same amount of drugs. They haven't discovered any drug resistance from those patients because the initial dosage that we used were based upon the factors not taking into consideration that uncertainty, right? because they didn't include that uncertainty, it skewed the data. It caused everything to be screwed up. And so after redoing it, we're still getting patients that don't show signs of drug resistance, right? And if it is, it's non-propagatable signs of drug resistance. Okay, so it does play a factor in real life. And Rihanna says, do you mind if we go over it again? I don't mind if we go over the subtraction part of it again. I'll give you another example here in a second.
Are we getting more examples of the multiply and a division?
I will give you another example of that too,
cool.
if you guys want.
All right, cool. Thank you.
So let's go do the multiplication and division, since that's what we're on, and then we'll go back to subtraction and addition. Is that fair?
Mm-hmm.
Yeah.
So let's say we have times. Okay. So how many sig figs do we have for this first number?
2.
2?
We have 2. The second number?
3.
And the last number?
2.
Okay. So if I go ahead and multiply this and then divide it by this, what do you guys end up with?
0.20, 0.202.
Okay, so how many sig figs should we have?
3? No, wait.
3. Wait, 2.
2.
2.
I should have 2. That's right. So my answer should be
0.2.
0 at the end, no?
a 0 at the end. That's right.
Oh,
That would be
0.2.
2 sig figs.
Yeah, because it's not exact.
Okay. Can you guys see that?
Yeah.
Okay. So let's do a subtraction one. Let's do. Okay. So what is the first thing that I want to do?
Find your lines.
Find my lines. Okay, so the first number, where am I drawing my line?
After 9.
After the 9.
And on the bottom one after 2.
Bottom one after the 2. Okay, so this spot is going to be my deciding factor, right? Okay, so let's do the math.
36,900. And then since it's greater than 5, would it be 37,000?
That's correct. Okay. Rihanna, does that help? I like it. Somebody's taking pictures.
You can hear that?
Yes, I can.
Oh.
It made like a sound.
Oh yeah, it's a screenshot from my MacBook. I've
Yeah.
been
Brooke
doing it a
said there was
lot.
like another way to take screenshots.
Yeah, but this is easier. I just,
Yeah,
Yeah.
it's like
The print screen.
no, it's annotate.
Yeah, if you go to annotate, you hit save.
Also, you can move the bar, by clicking the right side, drag it to the top, so it doesn't, conflict with everything on the screen, and then just press a button.
Brooke. Got it. I was stuck. I knew it was, I was like, to be a B, a B. Or an L, I couldn't remember. And then I had to look. Okay, so are there any questions on sig figs?
No.
Okay, so since we're not used to doing this all online, we're going to take it kind of slow for today. I'm going to actually stop. We'll stop after do one more problem.
Oh, a division one.
We're going to do this one.
Can you erase the squiggles? Thank you.
They're gone.
I couldn't see shit. Hold on.
Icky. Okay, what is it that I want to do? The numbers
find your line.
for you.
Who crashed?
What was
Student
that?
weighs a beaker and 4 different.
Find your line.
Find my lines. Okay.
Oh, so y'all read fast. Hold on.
So where is the line going to be drawn for the first number?
After the 5.
After the 5. What about
one's
the
after
second number?
After 6.
Are you sure?
Wait. After the 2.
Are you sure?
It's after the 6. No,
you
wait,
probably-
it's after the 0.
It's going to be after the last 0. That is correct.
Because it's got the decimal, so you get all of them.
Yep. Okay, what about the next number?
After the 9.
After the 9. And then what about the next number? We're at the 45.
After the 2.
After the 2. So same
And the last
spot
one
as
after the 3.
Okay, so they're both going to be at the same spot. So let's go ahead and do the math. It adds up to, and they give us the number there, 389.8389. Okay, so which number am I going to use to determine whether we're going to be rounding?
And that 3.
The 3. Okay, so are we going to round up or are we going to leave it alone? And what is going to be my value?
Leave it alone.
Leave it alone, okay. And then so my answer should be
389.8.
Wait, I forget. What's the
389.8.
question you asked to decide how many you're going over? Which one has the least or which one has the most?
It's always the one that has the most uncertainty. That's going to be our deciding factor, right?
Has most uncertainties. Okay.
Yes. And so we know that 319.5 has more uncertainty than the others because they have numbers that are going out further, right? Beyond the decimal. Right? So,
So it has the most or it has the unmost?
It has the most uncertainty, right? Because we don't have any numbers here. Do you see any numbers there?
Okay.
Only after the 5. Right? So there's no numbers there. So they could be, it could be 521, it could be 577, it could be anything, right? So we don't know about these numbers that will be following that 5, or it could be exactly just 5, right? We don't know, okay? Because we don't know anything about them because they're not there. So that's going to have more uncertainty than a number that is down here that goes to a further decimal spot, right? So they're pretty sure about that because they took the time to go further.
Okay.
Okay. So this is grams. Okay, questions? Concerns?
So
Tab?
so on the problems where we usually round up, if there's a 5, if it's by itself, you let it be. But if it's a 5 and there's a if there's a 5 but there's a number next to it, do you go based off the next number, correct?
Yep, and so you'd always
Okay.
round up, right? Because
If it's not a 0.
yeah. Did you guys ever use a teeter-totter?
What is that?
Yes.
Okay.
The
So
playground
we have a
thing.
kid, right? On one side. And then we have this other kid on the other side. And they weigh exactly the same, right? And then all of a sudden, this kid here decides to jump off and eat a sandwich, right? Wouldn't that kid weigh a little bit more than this kid?
Yeah.
And so what would happen? Wouldn't the
That kid will
teeter-totter
sink.
shift?
He'll go to the ground.
It's going to shift a little bit, right? The kid on the other side is going to go up. This guy is going to go down, right? Because he weighs just a little bit more. It's going to cause it to go up. So that's exactly what's happening here. So if we have 5, right? 5 is our mid. That's our middle point, right? But if we have 5.1, right? That means that we're going to go up a little bit.
Let's see.
Right? So anytime that you're looking at 5, let's say you're looking at the number 5, if there's numbers following it, that suggests that it's greater than 5. Right? That tells us that it's greater than 5. If there's nothing following it, if it's all zeros, then that tells us we're exactly at 5. And so we're playing it safe, right? Because then we're saying they're right at that even point. We're playing it safe and just saying, okay, it's right at 5, so we're not going to take that in consideration. Does that help, Jacob?
Yes, sir.
Good. Good. Okay, so we're going to stop early, really early today because, well, I have a lot to say, but, you know, we're just getting to being online for a little bit. So we're going to go ahead and try to take it a little slow because I don't want to overwhelm you too much. And sitting at the screen for like another hour would probably kill us.
But Dr. Henry, I believe you mentioned something about like the quizzes and what I missed, right?
Yes, I did talk to you about your quiz. I said I will give your quiz to Miss Norma, right?
All right.
And then what you miss, so I said you can look at the video to watch this because we're posting the videos for that.
I feel like there was something else though.
The note packet, you might know what you said you have it.
I think I do. I mean, I'm not sure.
Better
I'll check
have
it later.
Gabriel. It's on the computer.
But you can just print it out, so it's fine.
Yeah. And if not, I have a copy for you in the lab.
And you said until like the September 15th, right?
Yes,
It's going to be like this
Thursday
online.
will be online. Yes, until next Thursday we'll be online.
All right.
And then when you guys come back, we'll do a couple of labs to make up because you guys are missing today. Today was really a lab day. And then next Thursday or next Wednesday is also going to be a lab day that you're going to miss.
Are you fine?
I'm fine. Yeah.
I'm guessing it was another class.
It's because you guys had so many people. There were so many of you guys that tested positive. So like if we go over 4 people, then if we have more than 4 people test positive in a class, then they have to either move the class online or they cancel that day for a week or whatever. But they're not canceling my days because we're kind of hybrid anyway.
You can't just make the kids that test positive do the camera thing?
No, because then there's a possibility, since there were so many, there's a possibility that they passed it on. Even though it was a 3-day weekend and we know it's because people were turning up. They were at the beach and everything.
I did no such thing.
I mean, I haven't been in class since Monday. Last week.
And the funny thing is that it happened to like 3 classes, you know. We actually have to meet 3 classes that, and I figure it's probably all the same people, you know, that are taking those classes together. It is what it is. You know, we have this as a contingency plan anyway, right? We had planned on it just in case. That's why I gave you guys the Zoom link in the very beginning. And that's why we record the lectures.